Nick Petro with the National Weather Service in Raleigh with your 4 p.m. update here this Friday of the 23rd of January. Okay, so there have been a few more changes as the afternoon progressed. So I'm glad you're all with me here to go through this all. A winter storm warning is now in effect for much of central North Carolina, with the exception of, at least in the Raleigh coverage area, Wayne, Sampson, and Cumberland counties. So, you might be wondering, well, okay, why just an advisory further east? Well, this basically just boils down to amounts and impacts. So we expect the further you go south and east, the warmer it's going to be, the lesser the precip amounts, and overall the quicker change over to rain, which would basically, limit the impacts and the amounts anyway. So not to say that the advisory area won't see any freezing rain and ice, it's just not enough to trigger a winter storm warning. But that ties into impacts as well. So, if you're from anywhere from Fayetteville to Clinton to Goldsboro, yeah, it won't be quite nearly as bad as places further to your north and west. Okay, still some, like I said, still some hazards, but it will be a lot worse to your north and west. All right, so speaking of north and west, we made a slight westward nudge in the heaviest ice. I mean, subtle, not a huge westward nudge, but a little westward nudge in the heaviest. And then finally, this keeps cropping up as the storm has been trending warmer and warmer, but with the last batch of precip, when it moves through Sunday night, all associated with the cold front that will basically end the event. Once the cold front moves through, then all the precip pushes through. When that concludes, and out ahead of that warm front, we'll have one last pretty decent batch of precip. It could be warm enough for just rain as far north as the Triangle region. So yeah, that's the way things are shaping up here. Let's go ahead and go through the slides. Winter storm warning in effect for the pink counties, winter weather advisory for the purple or blue counties, and I kind of already elaborated to the what, when, and impacts. I'll hit on those here more in just a moment. But again, no major changes to the hazard table here. Still expecting, at the very onset, maybe a little coating of snow up near the Virginia border, but really most folks are going to see it start as sleet, and that won't be until the evening tomorrow, and then eventually it'll mix with and change, or change to, I should say, freezing rain and some ice accumulation. That would be more like Saturday night, overnight into Sunday morning. Again, the heaviest ice accumulations will be in the north and west across the Piedmont of North Carolina. Again, late Saturday, more like Saturday night through Sunday evening. Obviously, travel hazards will be a big deal. Black ice will continue to be a big deal subsequent nights. Where the heaviest ice accumulates will have the greatest concentration of power outages and fallen trees. And actually, there might be, you might think that the falling trees or power outages and falling trees are over, when you get up Monday morning, but it's going to turn pretty gusty, the wind, during the daytime Monday. So any tree limbs or tree branches that are just kind of dangling, the wind, it could be just windy enough to knock those down, and it could result in some additional power outages. So don't be surprised if you had power through the whole event, and then suddenly in the afternoon, just when you thought it was getting better, something new pops up in terms of a power outage. And then finally, we've been kind of emphasizing this point for a while now, but it's going to turn really cold behind that front by later Monday, when that cold Arctic air ushers in, and single-digit lows Monday night. Okay, so this is our forecast sleet total. We broke out the sleet. We did find a way in our internal system to create this map that just shows sleet. We were kind of merging it with the snow, but we found a way to break it out. And so, if you're basically up near Roxborough, Winston-Salem, and points north, there could be 2 to as much as 3 inches of sleet accumulation. Keep in mind, our winter storm warning criteria for sleet is only a ½ inch. So we're going to get, 6-8 times the amount that we would need of sleet for what would trigger a winter storm warning. So keep that in mind. Anyway, 1 to 2 inches of sleet from the Triangle westward and northward, maybe also up along the northern I-95 corridor, and then generally an inch or less of sleet, the lesser as you go further south, okay? Because the further south you go, the quicker it will change to freezing rain. And now speaking of that freezing rain, the image on the left shows basically the best case scenario. And essentially how we derive this is looking at the range of models. And the image on the left shows the lowest 10% of the model's configuration for freezing rain. Let me state this another way. There is 90% of the models show more ice accumulation than this. So 9 out of 10 models show more ice than this, okay? The one in the middle is the most likely outcome. And again, you could see that swath from Henderson, Roxborough, Durham, Burlington, Greensboro, Asheboro, Lexington, Albemarle. That's the corridor where we think the greatest number of power outages will be tree damage due to the heaviest amount of ice accumulation. But this is pretty much what we expect will happen, okay, with lighter amounts as you go south and east, particularly further you go east of I-95, the less, because it's going to change to rain there fairly quickly during the day on Sunday. And now the image on the right is kind of the worst case scenario. It's not the what's the word I'm looking for here? It's not the absolute worst case scenario, but 90% of the models show less ice than this. So this is like the top 10% of the models in terms of the highest ice amounts. 90% of the models show less ice than this. So that's why we show this as kind of a worst case scenario. It's that same corridor: Henderson, Roxborough, Burlington, Greensboro, Asheboro, Lexington, Albemarle. You know, if you know the top 10% of the heaviest icing models happen, that you could get an inch of ice, okay, which would be more prolonged power outages and you know, quite a big deal. Okay, so that's how you use these, as we call them, probabilistic ice amount numbers. Okay, which by the way are new this year. Last year we didn't have probabilistic ice, so this is definitely an advancement of predictability for us here at the National Weather Service. Okay, let's shift gears to well, before I show you this, let's switch gears for just a minute. And what I want to do is take you to the kind of the reflectivity simulations. Bear with me here while I change screens. Okay. So what are we looking at right here? Well, let me back this up. I don't want to get too far out ahead of myself. Let's look at current radar, and you can see that on this image here, look at the very light sprinkles that are occurring pretty much across central and southeast North Carolina. Yesterday, I thought we might have been able to get a 1/4 inch of rain out of this, but looks like it's underperforming. So for any of our DOT and you know public works folks who treat or pre-treat roads, this is probably good news for you, right? Less opportunity here with this light amounts to wash any brine off the road, so that's good news. So anyway, that will, and then as we look further west, you're probably wondering, well, where is all this precip that's coming in? And the idea is it's going to basically fill in and evolve to our west tomorrow. And that's why we're going to do an ongoing all-day live webinar tomorrow, so I can just kind of take you through in nowcast mode and give you frequent hourly or bi-hourly updates to show you the evolution of this. But anyway, as we switch gears to the models and see what the models are suggesting, give me just a moment to set this up. We're close enough to the event now where I can turn to what I would call our higher resolution, more detailed oriented models, okay? And what I've got here, I've got a couple things plotted. I've got simulated radar and precip type. I've got the surface temperatures, and what you want to focus on is the blue line, because that is the temperature at which the temperature is freezing. So let me highlight that for you. That's this blue line right here is 32 degrees. All right, so if you keep an eye on that. And then what we also have are the arrows, surface wind, the direction. So like these arrows here would be winds blowing from north to south. These arrows here would be wind blowing from west to east. So let's go forward in time and let's get to, basically this would be, you know, an hour from now, right? And as we continue to move forward in time, this is tonight, okay? It's quiet weather. Again, those few sprinkles will move away. And then let me just kind of fast forward to tomorrow morning, 7 a.m. tomorrow morning. And you'll notice, look at the precip really kind of blossoming to our west. And look where that freezing line is now, that blue line. It's pretty much pushed through North Carolina, much of North Carolina. And look at these arrows. So when you see, and we're getting a little bit into the meteorology 101, but this is 32 degrees, right? Freezing. And this is, gosh, I forget what number this verifies or represents, but it's a colder value. This is a warmer value, above freezing, right? But when arrows cross over these temperature lines, okay, that represents cold air that is moving into our area. So it's taking the cold air to our north and transporting it into our area. When you see those lines, arrows crossing over the temperature lines, okay? So I'll try to avoid the meteorological jargon so I don't confuse everybody, but just know that northerly winds bring in colder air, southerly winds bring in warmer air, right? Because warmer to the south, colder to the north. Anyway, this is 7 a.m., 8 a.m. tomorrow, 9 a.m., 10 a.m., 11 a.m., noon, 1, 2 in the afternoon, 2 in the afternoon, 3. You'll notice the freezing line hasn't really made much more progression southward. Kind of gets stuck there along the South Carolina border and eastward. So that is 3 p.m., 4 p.m. still quiet, you know. So by 4 p.m. we're still devoid of any kind of wintry weather hitting the ground or falling. That's 4 p.m., 5 p.m., 6 p.m. And actually, let me zoom in here. All right, so you can see just north of this freezing line, you can see some freezing rain breaking out here south of Goldsboro, east of Fayetteville. Okay, that's just in this one particular model depiction. That, again, that is 6 p.m., 7 p.m., 8 p.m. So you can see it's a little later than what we were talking about yesterday. That's 8 p.m. and it's just finally getting underway. And you'll notice that the blue represents snow. So right up near the Virginia border, yeah, there could be a little bit of snow at the onset with this mixed peat precip across, you know, just east of I-95. And as we continue to go forward in time, and notice the arrows are still suggesting cold air is coming in from the north. Okay, so that right there is 9 p.m., 10 p.m., and 11 p.m. And it's really getting going, particularly across the northern half of central North Carolina. So if you're down near Fayetteville, Laurinburg, Wadesboro, you know, if this model verifies, it doesn't really do anything even through the evening hours, because most of the actions is to the north, across the northern half of the state. So that's 11 p.m., midnight, 1 a.m., 2 a.m., 3 a.m. And what happened between 11 p.m. and 3 a.m.? It expanded. The coverage of the precip expanded. But you also notice the sleet also got kind of pushed to the north, right? Because even though these arrows suggest that it's getting colder and colder and colder, that is just at the surface. Let me remove those temperatures and let me put on here temperatures at 5,000 feet above the ground. And look where that freezing line is. It's to our north. And I wish I could put, well, there's the wind. Look at the wind at 5,000 feet above the ground, straight out of the south, okay? So you have surface wind out of the north, right? Bringing in colder air, and you have southerly winds bringing in warm air 5,000 feet above the ground, and even below that, even lower than 5,000 feet. So it's this vigorous southerly south to north flow is the whole reason why this becomes a freezing rain event. And look how far north the freezing line is. That's why it's snow up here and freezing rain down here, because once you get above, a couple thousand feet above the ground, it's well above freezing. Dare might I even call it warm. So if you wanna warm up, go up in the atmosphere tomorrow night. So anyway, let's continue to go forward in time, and I'll remove those temperature lines just to avoid confusion. So here we have 4 a.m., 5 a.m. Sunday, 6 a.m. Sunday, 7 a.m. Sunday, and we have pretty much freezing rain occurring across nearly all of central North Carolina. Now look at how we got rain not very far east of I-95, at least the northern I-95 corridor. It's much warmer at the coastal counties. So this is a strong signal for predominantly freezing rain, which makes sense given the southerly flow and how the warm air is coming in so vigorously from the south. All right, so that is 8 a.m. Sunday, 9 a.m. Sunday, 10 a.m. Sunday, 11 a.m. Sunday, noon Sunday, and 1 p.m. Sunday afternoon. Look what happens here. It kind of goes away, right? And we had been talking about this yesterday, that we started seeing this signal in the models even yesterday, that Sunday afternoon, the precip might really taper off across the eastern half of North Carolina, with freezing rain continuing across the western Piedmont. You see why the freezing rain values are much higher west of US 1? Okay, so let me draw US 1 in here, and that's why we're using that this is a very rough approximation for US 1. That's why we have the heaviest freezing rain west of US 1, partially because it might stop precipitating during the afternoon Sunday east of US 1. Okay, so this is far out as this particular model goes. So let me go ahead and switch to a different model. And it generally, and just bear with me here as I catch up to that same time frame. It's kind of the same model, just slightly different routes to it. But anyway, this is basically that same time frame on Sunday. Slightly different variation in the precip coverage. It even has less precip across a big chunk of central North Carolina. But suffice it to say that we're going to see precip rates really lessen up during the afternoons Sunday. And then the next second batch of heavier precip, and I apologize, I got ahead of myself here, is this batch here just moving into western North Carolina by 7 p.m. Sunday. And that's associated with the back end of the system, namely a cold front that's going to be sweeping from west to east. Okay. Now, as I mentioned before, what happens ahead of cold fronts? The wind turns to the south ahead of cold fronts. So here's the southerly wind that is, you see these arrows? This is at the surface. So no longer is the wind blowing from the north and bringing and reinforcing cold air ahead of this front. Now it's switching to the south, and that's bringing warm air at the surface in addition to above the surface. So that's why there's a pretty good chance that a larger portion of central North Carolina might actually see this end as rain. Look at that. Look at how the rain pretty much takes over. This time frame right here is 1 a.m. Sunday, 1 a.m. Monday morning. Okay, so midnight Sunday night, 1 a.m. Monday morning. Until that southerly air really kicks in, there still could be a period of freezing rain, between 9 p.m. and midnight Sunday night, basically along and north of Highway 64. Okay, basically also that freezing rain will hang on the longest north of the I-85 corridor as well. But the bottom line is a big chunk of the eastern Piedmont of North Carolina and the coastal plain, it could very well switch to rain and just end as rain. Okay. But again, as I mentioned earlier, by then it's quite possible that the damage will already have been done from the ice that accumulated earlier in the day. I guess the only good thing about it changing to rain is it might help to melt some of that ice, and maybe that'll help clear away some of the ice that would otherwise, be prolonged hampering to travel and hopefully would clear off the ice from trees and power lines. Maybe that'll kind of knock down the total number of down trees and down power lines that would otherwise occur if if the precip hadn't changed to rain. Okay, so you know, this, and then look, this is 4 a.m. Monday. Look, it's pretty much all rain east of I-95. It's warm enough. And then notice the wind direction changes to the west. That's the cold front having moved through, and cold air is coming back in behind that rain. And then it's pretty much by 10 a.m. it's over, and it's cooling down, I might add. So so anyway, let me go back to these slides, because another point I want to make is how cold air will rush in behind that front. Look how temperatures, this is every 3 hours, Saturday, Sunday, Monday, from time increasing from left to right. And a couple things I'll point out here. You know, from Saturday night through Sunday, look how cold it is. You know, we're talking teens and 20s. But then look how the temperature begins to warm up during the late day Sunday. And then after that front, it kind of steady state due to sunshine, but then it really cools down Monday night with single-digit lows Tuesday morning. But notice how in several locations across central North Carolina, I put these little red lines to denote when the temperature actually rises above freezing. And if there is no red line overnight, Sunday night into Monday morning, that means it's, you know, occurs much later in the day Monday. So you can see that places south and east of Raleigh will warm up above freezing earlier in the day. So places like Benson, maybe as early as late afternoon, you go above freezing. Places like Clinton, further south, by early afternoon, your temperature Sunday might go above freezing. You kind of get the idea now why we have I shouldn't say just, why we have a winter weather advisory rather than a warning, because it just probably the Sunday will probably just warm up quicker than maybe what we were already expecting earlier, and we end up being warmer and a better chance for rain in those southern tier counties. Fayetteville, kind of the same story, warming up above freezing during the afternoon, later afternoon Sunday. So again, a little bit more logic behind why we issued the advisory rather than a warning. Same thing for Goldsboro, Wayne County's in the advisory, an early warm up on Sunday. Where you don't see a red line, you'll notice that it stays below freezing Sunday evening and night. So Albemarle, Asheboro, Burlington, Durham, Greensboro, Henderson, Lexington, where else here? Roxborough, Winston-Salem. So the places that are further north and further to the west have a pretty decent chance of never going above freezing. And even that final push of precipitation when it moves through Sunday night might actually continue to collect as freezing rain. Okay, so you can almost use this as a proxy for determining when you go over from freezing rain potential to just plain rain potential. Okay, so earlier, the further south and east you are of Raleigh. Later, or not at all, the further north and west you are of Raleigh. Okay, so there's a lot of information that can be gleaned in this table. Okay, so again, you'll get this in your email here as soon as we wrap up this briefing. All right, let's now shift gears to wind chills, Monday night, Tuesday morning, below zero wind chills. And then our timeline, again, I went through this extensively here with those radar simulations, so I'm going to pass by. All right, so if I bundle all this up in just one slide of key messages, here's the takeaways. We got the winter storm warning in effect for much of central North Carolina, with the exception of the counties that I mentioned, Wayne, Sampson, Cumberland. Winter weather advisory there. It warms up sooner. There's lesser overall amounts. Sunday, it's a good chunk of Sunday's dry in those counties, so again, less accumulation of ice there. There has been a slight westward nudge in the heaviest ice accumulations. Now looks like the heaviest sleet and/or ice, greatest impacts, most power outages will be in that zone along and west of the US 1 corridor. And that honestly fits well with climatology, where the heaviest ice typically occurs with these types of systems. So no surprise there. Temperatures are now forecast to rise through the day and the evening Sunday. In advance of the last batch of precip and the cold front, it might even be warm enough that when that last batch of precip moves through, late Sunday evening and Sunday night after midnight, it'll be warm enough for just rain across central North Carolina, maybe as far north as the Triangle region. And as I pointed out, temps across the Triad and near the Virginia border, north of the I-85 corridor, will likely remain below freezing there even Sunday night, so maybe some additional freezing rain accumulation, okay? And that said, it's obviously that significant accumulations of ice are still possible across the Piedmont of central North Carolina Saturday night through Sunday. Again, the heaviest accumulations along and west of the US 1 corridor.